before humans became tall, we first became vulnerable. A taller body could see farther, walk longer, and carry more. But it also needed more food, more years to grow, and more care before it could survive alone. Height was not simply a gift from evolution. It was a cost paid slowly through bones, childhood, hunger, and generations. So what changed inside our world and inside our bodies that made this costly form possible? Why did humans become so tall? A tall human body can look like a simple improvement. It rises higher above the ground. It carries the head farther from the dust, the grass, and the small movements near the feet. It gives the eyes a wider field, the legs a longer reach, and the arms more space to work. But in evolution, almost nothing is free. Every shape that survives has to be paid for, not with money, but with food, time, risk, and the labor of generations. A taller body is not only a body with longer bones, it is a body that asks more from the world before it can stand on its own. This is where the question begins, not with pride, and not with the idea that height is always better, but with cost. Long bones need material. Growing tissue needs energy. A child who is going to become tall must keep eating, keep recovering, and keep growing through many seasons before the final shape appears. During that growth, the body is unfinished. It is alive, learning, and changing, but it is dependent. A young human cannot simply rise quickly into adulthood the way many animals do. The path toward a large adult body passes through a long childhood, and childhood itself is a form of vulnerability. So when we ask why humans became so tall, we are also asking why our ancestors could afford such a slow and expensive way of becoming adult. The earliest roots of the human story do not begin with giant bodies. They begin with primates whose lives were shaped by trees, food, danger, weather, and the need to move carefully through changing environments. Over time, some members of our lineage came to rely more on walking upright. That change did not immediately create tall modern humans. It changed the arrangement of the body first: the pelvis, the spine, the knees, the feet, and the balance of the head. Only later could longer legs and larger bodies become part of the pattern. Even then, a taller frame had to prove useful enough to outweigh its demands. A small body can be efficient. It needs less food. It can finish growing sooner. It may hide more easily, and it may survive hunger with fewer reserves. A large body can travel differently, lose heat differently, and face the world with a different reach, but it cannot escape its appetite. It must be supplied. It must be protected while young. It must survive illness and shortage long enough for its advantages to matter. This is the cold side of height. It is not a monument. It is a bargain. The human body became taller only in places, times, and populations where that bargain could continue across many births. Bones remember this bargain in a quiet way. A skeleton is not just a framework. It is a record of growth, strain, nutrition, disease, and recovery. Archaeologists and biological anthropologists can study ancient remains and see that height has never moved in one smooth upward line. It has risen, fallen, and varied, depending on climate, diet, health, and the pressures surrounding a community. That warns us not to treat height as a ladder of progress. A tall body can reflect strength in one setting, but stress in another setting may stop growth before it is complete. The same human potential can produce different adult bodies when childhood unfolds under different conditions. This matters because humans did not become tall in isolation. No child grows bones from genes alone. Growth requires food gathered by others, protection from danger, care during sickness, and time inside a group. In that sense, human height belongs not only to anatomy but also to social life. It carries the memory of shared meals, long childhoods, and environments that allowed vulnerable bodies to keep growing. Before height could become familiar, human ancestors had to survive the cost of being unfinished. A taller body does not begin when a person stands at full height. It begins much earlier, when the body is still small, soft, and incomplete. Long before the adult skeleton is visible, growth is already making demands. Cells divide, bones lengthen, muscles thicken, blood vessels spread through new tissue. The brain, already hungry for energy in humans, continues to develop while the rest of the body is also asking for food. This makes human growth unusually expensive. It is not only the final adult who needs nourishment, it is the growing child, year after year, who must receive enough energy for the body to keep building itself. In many animals, the young become independent more quickly. They still need care, but the period of helplessness is shorter. Human children follow a slower road. They walk, speak, learn, and join the group gradually, while their bodies continue changing for a long time. A future tall adult is therefore a long investment. The group must keep that child alive through hunger, cold, heat, infection, injury, and weakness. If food is scarce for too long, growth can slow. If disease returns often, energy may be spent on survival instead of height. If childhood is harsh, the bones may never reach the size that genes alone might have allowed. This is why height cannot be understood as a simple inherited number. It is a conversation between biology and the world. The body may carry a plan for growth, but the environment decides how much of that plan can be completed. Near the beginning of the human lineage, this would have mattered deeply. Our ancestors were not living outside nature, protected from every shortage. They moved through landscapes where food changed with seasons, where water mattered, where danger was real, and where young bodies could not provide for themselves. A taller adult body could only become common if enough children survived the long path required to become one. That path needed calories, but also cooperation. A child cannot digest a social structure, yet social life can decide whether the child eats. Food shared by adults, protection given by kin, and knowledge passed through daily habits all become part of the hidden foundation of height. The growth of a human leg bone is not only a private event inside the body, it is also tied to hands that gathered, carried, cut, cooked, guarded, and fed. This is one reason human height points back to the origin of humans more clearly than it first appears. It shows that our bodies evolved along with dependence. We did not simply become upright walkers with longer limbs. We became creatures whose young needed time, and whose adults had to make that time possible. A tall body is slow to arrive, and slowness can be dangerous. A longer childhood gives room for learning, but it also leaves a young person exposed. More years before full strength means more years when others must help. In a world without stored medicine, modern shelter, and guaranteed food, that dependence was not a small detail. It was a central condition of becoming human. This does not mean early humans planned to grow tall or that they understood height as a goal. Evolution does not need a goal in the human sense. It works through survival and reproduction across generations. If certain body shapes helped some groups move, endure heat, search for food, or raise young more successfully, those shapes could become more common. But each advantage had to pass through childhood first. No adult trait matters if the young cannot reach adulthood, so the question of height quietly becomes a question of care. How did a species with such costly children continue to survive? How did bodies that needed so much food and time become ordinary enough to define us? The answer begins with the fact that height was never carried by bones alone. To ask why humans became tall is not the same as asking why height is useful. Usefulness is only one side of the story. The deeper question is why a costly body could keep appearing, generation after generation, without being erased by hunger, injury, disease, or the long weakness of childhood. A body does not become taller because height sounds impressive. It becomes taller only if the whole life around that body can carry the burden. This is why the first answer must begin with the price. A longer leg can make each step reach farther, but the leg has to be grown first. A larger frame can hold strength, but the frame has to be fed. A higher pair of eyes can look across open ground, but those eyes belong to a body that spent years needing protection before it could walk confidently through danger. Nothing about height floats above survival. It is tied to the ground, to food, to mothers and fathers and kin, to seasons that were generous or cruel, and to the quiet mathematics of childhood. If a young human lacked enough nourishment, growth could pause. If illness returned again and again, the body might spend its energy simply staying alive. If a community could not support many dependent children, then the path toward a tall adult body would narrow. In this way, height becomes a trace of conditions, not a trophy. It tells us that some ancestral bodies were shaped in worlds where larger size and longer limbs could be sustained often enough to matter. This does not mean every human group moved in the same direction. The fossil and archaeological record shows variation, and later history shows even more. Human height has never been a straight road upward. It has moved with climate, diet, disease, migration, social change, and the uneven lives of children. That is important because the origin of human height belongs to a long and uneven process, not to a single moment when our ancestors suddenly became tall. Before there were modern humans, there were earlier members of our lineage whose bodies were already experimenting in the slow language of evolution, with upright walking, changing proportions, and new ways of moving across landscapes. The beginning of height was therefore not a simple growth spurt of the species. It was a shift in the relationship between body and world. Standing upright changed how weight passed through the hips, knees, and feet. Longer legs could later make movement more efficient over distance. A taller body could interact differently with heat and open space. But all of these possibilities remained limited by one question. Could the young survive long enough to become adults? This question keeps the story honest. It prevents us from turning height into destiny, or from pretending that evolution always makes bodies better in a simple way. A smaller body can be a wise answer to some environments. A larger body can be a wise answer to others. The human form that feels normal to us today is only one result among many possible compromises. It carries advantages, but it also carries debt. Each adult height is built out of old exchanges between energy and need, movement and danger, growth and care. When we look at a tall human body, we are not only seeing length, we are seeing a long childhood that did not end too soon. We are seeing food that arrived often enough, illness that did not always win, and a social world that made slow growth possible. So before asking what height allowed humans to do, we have to ask what kind of human world allowed height to exist at all. That question opens the path ahead, because the next clues are not found only in bones, but in the first great change that lifted our ancestors onto 2 feet and kept them there through deep time. The human body can feel so familiar that it is easy to forget how unusual it is. We stand with the spine balanced above the hips, the head resting over the chest, the knees placed under the weight of the body, and the feet stretched into platforms for walking. This arrangement feels ordinary because it is the only body plan we have ever known. But deep in the human past, our ancestors did not begin as tall walkers moving calmly across open land. They began as primates with bodies shaped by older ways of living, bodies that carried the memory of climbing, grasping, balancing, reaching, and moving through broken spaces. Their world was not a stage built for human height. It was a changing patchwork of trees, ground, shade, fruit, leaves, insects, water, predators, and distance. In that older world, being small was not a failure. A smaller body can move through branches more easily. It can need less food. It can use cover and flexibility in ways a larger body cannot. Early members near the root of the human lineage were not simply short versions of us. Their arms, legs, hips, hands, feet, and skulls belonged to a different balance of life. Some features pointed toward upright walking, while others still carried traces of climbing and life above the ground. This is one reason the story of human height must move slowly. A tall, modern body did not appear first, waiting for evolution to explain it later. The body had to be reorganized piece by piece, over long stretches of time before greater height could become one possible outcome. The first question is therefore not why humans became tall, but how a lineage of primates began to carry its weight in a new way. Upright walking matters because it changed the foundation of the body. When an animal moves on 4 limbs, weight is shared across the forelimbs and hind limbs. When a body walks on 2 legs, the hips, spine, knees, ankles, and feet must take on new roles. Balance becomes a quiet problem with every step. The pelvis must help support organs and muscles differently. The spine must curve in ways that keep the upper body from falling forward. The feet must stop acting mainly like grasping tools and become structures for pushing against the ground. These changes did not make early humans tall by themselves, but they opened a path. Once walking on 2 legs became important, the legs could begin to matter in a new way. Length, stride, energy use, and endurance could slowly become part of the evolutionary conversation. Still, it is important not to imagine a clean break between ape-like ancestors and human-like walkers. The fossil record does not show a simple ladder. It shows many forms, many experiments, and many bodies that do not fit neatly into modern categories. Some were small, some had long arms compared with their legs. Some walked upright in certain ways while still keeping abilities useful for climbing. This mixed evidence keeps the story grounded. Human height did not begin as an instant transformation from the forest to the plain. It began with bodies living between possibilities. They could use the ground more than before, but the old world had not disappeared. Trees still mattered. Food still mattered. Safety still mattered. The first steps toward the human shape were not heroic. They were practical and uneven. A body that stood more often could carry objects differently, see over low vegetation in some settings, move between food sources, or free the hands for tasks while walking. None of this proves a single cause, and scientists continue to discuss the exact pressures that favored upright walking. But the broad point is widely accepted. Bipedalism came before the tall body that later became typical of our species. Height rested on an older architectural change. Before humans could become tall in the way we recognize, they first had to become creatures whose bodies were organized around the ground, the hips, and the long work of balancing on 2 feet. Walking on 2 feet looks simple only because the body hides its difficulty. Each quiet step is a negotiation with gravity. The whole weight of the upper body must pass down through the spine, into the pelvis, through the knees, along the ankles, and finally into the ground. For a 4-limbed animal, balance is spread across more supports. For a human, the body has to fall forward slightly and catch itself again, and again. This repeated act required a deep reworking of anatomy long before modern human height could become familiar. The pelvis had to become a basin that could hold the organs while also anchoring muscles that steady the body during walking. The spine had to develop curves that bring the head and trunk over the hips instead of letting them lean too far forward. The knees had to angle inward enough to place the feet beneath the center of weight. The feet had to lose much of their old grasping role and become firm, springing platforms. These changes were not decorations added to an already human body. They were the foundation that made a different kind of body possible. In the early human lineage, upright walking did not mean that every ancestor looked like us. Some bodies still carried signs of climbing. Some hands and arms remained useful for reaching and holding. Some feet and shoulders suggest a life that was not purely on open ground. That mixed form is important. It reminds us that evolution does not erase the past in one clean motion. It adjusts older structures for newer pressures, often leaving a body that belongs to more than one world. The origin of human height has to be understood within that mixed condition. A longer leg is only useful if the rest of the body can manage it. If the hips cannot balance the trunk, a longer stride becomes unstable. If the spine cannot hold the head above the pelvis, height becomes a burden. If the feet cannot push and absorb force, each step wastes energy. So the path toward taller bodies first required a body that could stand, shift weight, and move forward without using the arms as main supports. This was a quiet revolution, not because it happened suddenly, but because it changed what later evolution could work with. Once the hands were less tied to locomotion, they could be used more often for carrying food, infants, tools, or gathered objects. Once the legs became the main engines of travel, their proportions could matter more directly to movement across distance. Once balance centered over the hips, the whole silhouette of the body could begin to stretch upward in a new way. But none of this should be mistaken for a simple purpose, as if early humans stood up in order to become tall. Evolution does not move by foresight. It preserves small differences when they help bodies survive and reproduce in real environments. Upright walking may have offered several possible benefits depending on time and place. Moving efficiently between food patches, carrying objects, reaching for food, traveling through more open habitats, or managing heat differently under the sun. Scientists continue to debate the weight of each factor, and the safest answer is not to choose only one. The change likely belonged to a broad pattern of shifting environments and shifting behaviors. What matters for the question of height is that bipedalism changed the rules. In a body built around four-limbed movement, height is constrained by a different architecture. In a body built around two-legged walking, the legs become more central to survival. Their length can influence stride, energy cost, range, and the ability to move through space. This connects directly back to the beginning of the human story. Our ancestors did not become tall first and then learn to walk like humans. They became increasingly committed to upright movement, and only after that commitment did longer legs and larger bodies become more meaningful. The fossil record shows this as a gradual and uneven pattern, not a clean staircase. Some early hominins were small but already walked upright in important ways. Later forms show body proportions closer to long-distance walking. This sequence matters because it keeps the story honest. Height was not the first human trait. It grew out of older changes in posture, balance, and movement. Before the human body could rise higher, it had to learn how to carry itself on 2 feet without falling back into the older design. Standing upright opened a door, but it did not decide what would walk through it. Early humans could balance on 2 feet and still remain relatively small. They could carry their weight over the hips and still live in bodies very different from ours. This is important because upright posture is only the beginning of the human frame. It changes the architecture, but it does not automatically create height. A house can have a new foundation and still be built low. In the same way, a lineage can become bipedal before it becomes long-legged, tall, and shaped for wider travel. The first changes were about balance and support. Later changes had to do with distance, energy, heat, food, danger, and the kinds of landscapes our ancestors crossed. A taller body needs a reason to keep returning across generations. If standing on 2 feet had been enough by itself, then every upright ancestor would have looked much closer to modern humans. The fossils do not show that. They show variety. Some early hominins had small bodies and features that still connected them to climbing. Others, later in time, show longer legs and proportions that suggest more efficient walking over distance. This tells us that the human body was not moving along a single straight line toward height. It was responding to changing conditions, one compromise at a time. The origin of human height sits inside that slow sequence. First, the body learned to carry itself differently. Then, under certain pressures, longer lower limbs could become more useful. But even usefulness had limits. Longer legs can improve stride and reduce the energy cost of walking in some settings. Yet they also require longer growth, stronger bones, more food, and a childhood that lasts long enough to complete the design. The earlier bargain remains. Height is never only a shape. It is a demand placed on the whole life cycle. This is why the move from upright walking to tall bodies had to pass through population and environment, not just anatomy. A child born with the potential for long limbs still needed enough nourishment to grow them. A group living in a place where travel mattered might benefit from adults who could move efficiently. A warmer, more open landscape might make a long, relatively narrow body useful for releasing heat. A community that shared food and protected young ones might allow slow growth to continue. None of these factors alone gives a complete answer, but together they help explain why bipedalism was necessary without being sufficient. It prepared the body. It did not finish the story. The first humans were not made tall by the simple act of standing. They were shaped by what standing made possible over deep time. Once the arms were less involved in locomotion, once the legs carried the daily burden of movement, once the body's balance centered over the hips, evolution had new material to work with. Legs could lengthen, the stride could change, the torso could be carried differently above the pelvis. The body could become better suited to moving across ground rather than only through trees. But that transformation remained gradual, uneven, and dependent on survival. A taller young body that failed to reach adulthood left no long trace. A costly body that survived often enough could become part of a lineage. In this quiet way, upright walking became the doorway through which height later entered human history. It gave our ancestors a new relationship with the ground. It made the legs more central than before. It changed the meaning of distance. Yet the full rise of the human body would require more than posture. It would require open spaces, repeated movement, heat, food, childhood, and care. The question now turns from the skeleton itself to the world around it, because a body does not become tall in empty space. It becomes tall only where the ground, the climate, and the journey make such a body worth its cost. The story of human height cannot stay inside the skeleton for long. Bones change in bodies, but bodies live in places. The ground under the feet, the distance between foods, the shade of trees, the heat of the day, and the danger moving through a landscape all help decide what kind of body can survive. In the early history of the human lineage, Africa was not a single unchanging background. It held forests, woodlands, river edges, lakes, grasslands, dry corridors, and shifting mixtures of these habitats. Over long periods, climate varied, and the boundaries between wooded areas and more open spaces changed many times. This does not mean our ancestors suddenly left a dense forest and stepped into an empty plain. That older image is too simple. The more careful picture is one of patchy environments, where trees still mattered, but the ground between trees began to matter more. In such a world, a body that could walk upright was not only standing differently, it was entering a new relationship with distance. Food might not always be nearby. Fruit, tubers, seeds, insects, small animals, water, and safe resting places could be spread across a wider area. Moving between them required energy. A body that wasted too much energy with every step would pay for it through hunger and fatigue. A body that moved more efficiently could return with food, follow seasonal opportunities, or cross exposed ground with less cost. This is where longer legs begin to enter the story, not as a sudden invention but as a possible answer to space. Near the roots of humanity, the world did not ask only whether an animal could climb or grasp. It also began to ask how far it could travel on the ground, how often it could do so, travel on teen, and how much energy remained afterward. A short, compact body can be successful in many settings, and early hominins were not wrong bodies waiting to become correct. They were living forms suited to their own time, but as some lineages used the ground more, the length and shape of the legs became more important. A longer leg can allow a longer stride. Under the right conditions, it can reduce the effort needed to cover distance. It can help a walker move across broken ground with a rhythm that saves energy over many steps. These advantages would not matter much if food and safety were always close. They become more meaningful when the landscape is wider, more seasonal, and less predictable. The beginning of human height is therefore tied to an expanding sense of range. Our ancestors did not grow taller because open country simply rewarded height in every case. They grew within a complicated set of pressures, where upright walking, body proportion, food search, and climate interacted slowly. Fossils from different times show that body size and limb proportions changed unevenly. Some early forms remained small. Later members of the genus Homo generally show longer legs and bodies more suited to travelling on the ground, though variation remained. That pattern fits a world where movement became increasingly central, but never in a simple or universal way. The key is not to imagine a heroic march across the savannah. It is quieter than that. It is the repeated need to move from shade to water, from one food patch to another, from safety to opportunity. Each journey was ordinary. Across generations, ordinary journeys can shape extraordinary anatomy. Human height began to make sense when the body's daily path stretched farther than before. The taller frame was still costly, still slow to grow, still dependent on childhood care. But in landscapes where distance became part of survival, a longer-legged body could begin to repay some of what it demanded. The next question is how those distances change the meaning of walking itself. A landscape becomes powerful not only by what it contains, but by how far apart those things are. For an animal that lives close to one food source, the body can remain tied to a small circle of movement. For a lineage that must cross from one patch of food to another, from a place of shade to a place of water, from a safe sleeping area to a feeding ground, distance begins to write itself into the bones. Early humans did not need to understand this. They only had to live it. A day of searching, walking, pausing, turning, and returning could place quiet pressure on the body. Each step used energy. Each mile, if repeated often enough across many lives, became more than movement. It became a condition of survival. This is where long legs may have mattered. A longer lower limb can help increase stride length. In the right body and in the right environment, it can make walking over distance less costly. That does not mean taller bodies were always better. It means that in some settings, especially where resources were spread out, a body that travelled efficiently could gain more than it spent. The human story began in such ordinary exchanges. A little less energy spent on walking could mean more energy left for carrying food, feeding children, recovering from illness, or surviving the next uncertain day. This connects height back to the origin of humans in a very direct way. Our ancestors were not simply becoming taller in appearance. Their bodies were entering a life in which the ground between things mattered. When the arms were less involved in movement, the legs became the main instruments of travel. When walking became common, the length, strength, and efficiency of the legs became more important than they had been in a climbing-centered body. The change was not only about reaching a destination. It was about what remained in the body after reaching it. A tired body searches less well. A hungry body takes greater risks. A parent or caregiver who can move farther with less effort may bring back more food or return more reliably. Across generations, these small differences can become meaningful. Still, we have to stay careful. We cannot say that every early human walked across open grasslands in the same way, or that long legs evolved for only one task. The evidence suggests changing habitats and mixed behaviors. Some environments were wooded, some were more open, some shifted with climate. The bodies of early hominins also varied. But the broad pattern is clear enough to hold. Later, human relatives became more committed to ground travel, and longer legs became a stronger feature of that commitment. Walking farther does not require only anatomy, it also requires knowledge. A group moving through a broad landscape must remember where water can be found, when certain foods appear, which routes are dangerous, and where shelter may be possible. These are not just thoughts floating above the body, they shape movement. A body that can travel well is more useful when paired with memory, social learning, and shared attention to place. In this sense, the human body did not become tall alone. It grew taller inside a way of life that tied legs, eyes, hands, memory, and group behavior together. Distance also changes danger. Moving across open ground can expose a small body to heat and predators. Height can help the eyes notice movement over low vegetation, but the same height can make a body visible. Longer legs can help with steady travel, but they must be grown slowly and maintained with food. Again, the bargain returns. A long-legged body was not a free answer to the landscape. It was a risky investment that had to pay back through movement, endurance, and survival. The reason this matters for the central question is simple. Humans did not become tall because height itself was magical. They became taller through conditions in which the daily act of moving through space became important enough to shape the body. The first clue was standing upright. The next clue was distance. When the world spread food, water, danger, and shelter across wider ground, the body that could cross that ground with less waste began to carry a quiet advantage. Over time, the long human leg became not just a limb, but a record of journeys repeated so often that they entered our form. A taller body can be understood as a slow answer to a wider world. Not an answer spoken by the mind, and not a choice made by a single ancestor, but an answer written gradually through survival, growth, and movement. When food, water, shade, and safety lie close together, a small range may be enough. The body does not need to pay for long limbs if short movements solve the daily problem, but when the useful places of life are spread farther apart, the ground itself begins to shape the animal moving across it. In the early human story, this widening of space did not happen all at once. It came through changing climates, shifting woodlands, open patches, river edges, dry seasons, and the uneven distribution of food. The world became a mosaic, and the body had to cross it. A long-legged walker could, in some situations, cover more ground with less effort than a shorter-legged body of similar design. That difference may seem small across one morning, but evolution is often built from small differences repeated across deep time. A little less energy spent walking could leave more energy for carrying food, feeding children, healing, or simply reaching the next place before heat or danger became too great. This connects directly to why human height cannot be separated from the beginning of human movement on land. Our ancestors were not just bodies standing upright in one place. They were living in landscapes that required decisions made through motion, where to go, what to gather, when to return, which route was safer, and how far the group could travel before the day became dangerous. The legs were no longer only supports, they became the long instruments of range. Height in this setting was not merely vertical, it was horizontal as well. A taller body held a longer stride, and that stride belonged to journeys across the ground. To become taller was, in a quiet sense, to become shaped by distance. Yet distance alone cannot explain everything. A body can be built for movement and still fail if it cannot grow. Long limbs must be supplied during childhood. A young human with the potential for height still needs food through many years. This is why the story always returns to care. The widening world may have favoured efficient travel, but only a group capable of feeding slow-growing young could turn that pressure into adult bodies. A long-legged child is not born ready for long journeys. The child must be carried, watched, taught and fed before those legs can repay their cost. So the wider landscape did not shape isolated individuals. It shaped populations, families and social habits. The ground pulled the body outward through movement, while the group held the child long enough for growth to finish. The fossil record gives this story weight, but not a simple ending. Earlier hominins show bodies that were often small and mixed in their adaptations. Later human relatives show stronger signs of long-distance walking, including longer legs and changing body proportions. Still, variation remained, and no single fossil can explain all of human height. What we can say with care is that the rise of taller, longer-legged bodies fits a life increasingly organized around walking, traveling, and surviving across broader spaces. It was not a straight march toward modern height. It was a gradual adjustment to a world where the next necessary place might be farther away than before. Seen this way, human height becomes less like a measurement and more like a memory. It remembers the open distance between trees. It remembers dry ground between water sources. It remembers food that did not wait in one location. It remembers children growing slowly while adults moved, searched, returned, and shared. A taller body was not simply raised upward. It was stretched by the long demands of space. Height is not only a matter of reaching upward, it also changes how a body meets heat. A taller human body usually has a different relationship between length, surface, and mass than a shorter, more compact body. This matters because early humans did not move through a cool and effortless world. They moved under the sun, across broken ground, between shade and water, and through landscapes where distance could make the body warm long before the day was over. Heat is one of the quiet pressures in human evolution. It does not always leave a dramatic mark, but it can decide whether a body keeps moving, slows down, or fails. Muscles produce heat when they work. Walking for a long time, especially in warm conditions, turns the body into a living engine that must release what it produces. If heat cannot escape, movement becomes dangerous. The brain, the organs, and the muscles all depend on a narrow balance inside the body. This is why the shape of the human body cannot be separated from climate and endurance. Compared with many animals, humans became unusual not only because they stood upright, but because they could cool themselves in a special way. We have many sweat glands, and we can release heat through sweating across much of the skin. We also have relatively little body hair compared with many other primates, which may have helped sweat evaporate more effectively. These features did not make humans tall by themselves, but they made a taller, longer body part of a broader system for moving in the heat. A long, relatively narrow body can expose more skin to the air compared with a compact form of the same mass. That can help heat leave the body more easily. In hot environments, this kind of shape may be useful, especially for an animal that walks far and depends on endurance rather than short bursts of speed. The origin of human height, therefore, belongs not only to the legs and hips but also to the skin. It belongs to sweat, airflow, sunlight, and the slow challenge of keeping the body cool while the feet keep moving. Earlier members of the human lineage did not all have the same body proportions. Some were smaller and more mixed in their abilities. Later human relatives, especially those more committed to ground travel, show forms that fit more sustained movement. Scientists are careful with this evidence, because fossil bones do not preserve sweat, skin, or daily behavior directly. But the broad pattern of human anatomy suggests a body increasingly able to travel in warm, open settings without overheating as quickly as many other mammals. This does not mean early humans were invincible in the heat. They still needed water. They still needed shade. They still faced danger from dehydration and exhaustion. Sweating itself is costly because it loses fluid and salts. A cooling system that depends on sweat can only work where water can eventually be found. Again, the human body reveals a bargain. The same system that helps release heat also creates new needs. The same tall form that may help cooling must still be grown, fed, and protected. Height is never separate from the conditions that make it livable. When we imagine the beginning of human tallness, we should not picture height as a simple advantage towering above the landscape. It may be better to imagine a body walking slowly under a pale sky, heat rising from the ground, skin releasing sweat, legs carrying weight from one place to another, and a group moving with enough knowledge to find water, rest, and food. In that scene, height is part of a living balance. It helps only if the body can cool itself, only if the child can grow into it, and only if the world around the group offers enough resources to support its cost. The human body became not merely taller, but more deeply connected to heat, endurance, and the open air. A long, narrow human body makes the most sense when it is placed in motion. Standing still, height may look like a simple vertical fact. Walking for hours under warmth, it becomes part of a cooling system. A compact body holds heat differently from a longer, more slender one. The difference is not magic, and it does not work in every climate in the same way, but it helps explain why body shape can matter as much as body size. In warm environments, an animal that moves for a long time must solve two problems at once. It has to spend energy to travel, and it has to release the heat created by that travel. If the body is too poor at releasing heat, even strong muscles become limited. The legs may still be able to move, but the inner temperature begins to rise, and the animal must slow down, rest, seek shade, or risk harm. Humans became unusual because our bodies are not built mainly for sudden speed. We are not the fastest runners. We do not have claws, heavy fur, or the strength of many large animals. Yet our lineage developed a form of endurance that depended on steady movement, heat release, and careful regulation of effort. A taller, more linear body can be part of that pattern because it offers more surface through which heat can leave. Long limbs also place moving muscles away from the central trunk, where the most vital organs are held. This does not mean tallness alone caused endurance. It means that height, limb length, sweating, reduced body hair, upright posture, and walking ability may have worked together as a system. The beginning of the human body was not one change, but many changes slowly fitting into one another. Upright posture reduced the amount of direct midday sun hitting the top of the body compared with a horizontal back, though sunlight and heat still remained serious pressures. Sweating allowed evaporation to cool the skin, but only when water was available and air conditions allowed it to work well. Longer legs could make travel more efficient, but only after the pelvis, feet, spine, and muscles were able to support that movement. A narrow body could release heat more easily than a broad, compact one, but it still needed food to grow and maintain. This is why the human form should be seen as a compromise, not a perfect design. Every benefit brings a cost. Sweat cools the body, but it uses water. Long legs help cover distance, but they take years to grow. A slender body can handle heat, but it may lose warmth more easily in colder settings. No single body shape is best everywhere. It is best only in relation to a world. For early humans and their relatives, the world included warm days, uneven ground, long searches for food, and the need to keep moving without collapsing under heat. The body that could walk steadily, release heat, and recover might have had a quiet advantage. Not every day would reward that body. Not every landscape would demand it. But across enough journeys, enough dry seasons, and enough generations, the advantage could become meaningful. This returns us to the origin of human height in a more careful way. Humans did not become tall because tallness itself was the goal. A taller, longer body became possible because it could join other traits that helped our ancestors live through movement. The skin mattered as much as the bones. Water mattered as much as the stride. Shade, timing, group knowledge, and memory of place mattered as much as muscle. A person walking through heat is never only a skeleton in motion. The whole body is working. Blood moving warmth outward, sweat reaching the skin, breath settling into rhythm, feet meeting the ground, eyes searching for the next safe place. If we imagine the deep past with honesty, we should not turn this into a dramatic chase or a simple victory over nature. It was more likely a long pattern of ordinary movement repeated until it became anatomy. A body that could keep going in warmth, without overheating too quickly, could reach food, return to others, and help support children who were still years away from independence. In that slow exchange, height became tied to endurance. The human body rose not only to see farther, but to carry heat away while moving through a wide and difficult world. Heat changes the meaning of height. In a cool room, a tall body may seem only longer than a short one. Under an ancient sun, after hours of walking, it becomes a body negotiating with warmth, water, air, and exhaustion. The human form did not rise in a world without weather. It rose in landscapes where the body had to keep its inner temperature within safe limits, while still searching, carrying, watching, and returning. A taller, longer-limbed shape could help in that negotiation because it may release heat more effectively than a compact shape of the same weight. But the advantage was never separate from the surrounding climate. In a hot open place, long limbs and a narrow trunk can support cooling. In colder places, the same shape can lose warmth too quickly. This is why human height cannot be called simply better. It is better only within certain conditions, and only when other needs are met. The beginning of human tallness belongs to those conditions. Our ancestors were not just becoming walkers, they were becoming walkers in real air, under real sunlight, with real limits on water and food. Sweat gave the human body a remarkable way to cool itself, but sweat also created dependence. A sweating body needs water. A body that loses water must know, or be guided by the group, where water can be found. A long day of movement could not be separated from memory of rivers, pools, shaded places, and safe returns. In this sense, climate did not shape height alone. Climate shaped behavior, and behavior shaped the value of the body. A long-legged person moving across warm ground needed more than anatomy. They needed timing. They needed rest. They needed knowledge of place. They needed others, especially while young, because the body that would one day travel far first had to survive years of helpless growth. This keeps the story connected to the origin of humans. Height was not added to a finished creature. It grew within a way of life where walking, sweating, remembering, sharing, and caring slowly became linked. Endurance also changes how we think about strength. Many animals are stronger in a sudden contest. Many are faster over a short distance. Human bodies became distinctive in another way. They could often continue at moderate effort, regulating heat through skin and sweat while moving across ground. This does not mean early humans always traveled far every day, or that every tall body was made for one purpose. The evidence is not that simple, but the general pattern suggests that sustained movement in warm environments helped give meaning to longer legs and taller bodies. Height, then, is not only a number measured from feet to head, it is a record of the body's relationship with heat. It remembers sunlight falling on upright shoulders instead of a horizontal back. It remembers air moving around limbs. It remembers skin releasing moisture so the inner body could remain calm enough to continue. It remembers the cost of water, the danger of overheating, and the value of moving without burning through all available strength. It also remembers limits, because a body shaped for cooling may struggle when warmth disappears, and a body shaped for endurance may still be stopped by thirst. As human relatives spread into different regions and later populations lived under different climates, body size and proportions varied. That variation is important. It reminds us that no single human shape represents the whole story. Tallness became one possible answer among many, shaped by heat, distance, food, disease, and childhood. In warm open worlds, a taller and more linear body could help carry movement farther, but such a body still needed energy to grow. The next clue, therefore, must come from food, because no body can become tall on climate alone. A tall body cannot be built from posture alone. It cannot be built from distance alone, or heat, or open ground. All of those pressures may help explain why height became useful, but usefulness does not feed a growing child. Before any long limb can become an adult advantage, the body must receive enough material to build bone, muscle, blood, skin, and organs. Growth is a slow act of construction. It takes energy every day, not just in rare moments of plenty. This makes food one of the most important clues in the rise of human height. A taller adult body is not only larger at the end, it is more expensive all along the way. The child who may become tall must survive many years of eating, digesting, healing, sleeping, and growing. If food is too poor or too uncertain, the body may protect itself by slowing growth. Survival comes before height. A hungry body does not spend freely on length when it must keep the heart beating and the brain alive. This is why the question of human height must pass through diet. Our ancestors could not become taller in any lasting way unless their food world changed enough to support it. Early members of the human lineage lived by gathering, searching, digging, cracking, cutting, chewing, sharing, and learning where edible things could be found. The exact diet varied across time and place, and it would be wrong to imagine one single ancestral menu. But the general problem was constant. The body needed energy, and the growing body needed even more. Plant foods could provide important nutrition. Underground storage organs, fruits, seeds, nuts, leaves, and other resources may all have mattered in different settings. Animal foods also became significant in the human story, especially because they can provide dense energy and nutrients. This does not mean early humans suddenly became powerful hunters in a simple dramatic scene. The evidence suggests a long, uneven history of scavenging, hunting, gathering, processing, and sharing. What matters for height is not one heroic behavior, but the gradual widening of the food supply. A body that walks farther may reach more foods, but it also spends energy reaching them. A body that grows taller may travel more efficiently as an adult, but it must first be fed through childhood. The food system had to support that circle. As tools became more important, they changed the relationship between body and food. Cutting, scraping, pounding, and breaking could make certain resources easier to use. Later, cooking changed digestion in a major way by making many foods softer, safer, or easier to extract energy from, though the timing and details remain complex in scientific discussion. It is safest to say that food processing, including tool use, and eventually cooking, helped humans gain more usable energy from the world around them. That extra energy did not go only to height. It also supported the brain, reproduction, activity, and survival. The human body was managing many demands at once. Still, without more reliable access to energy, a costly body plan would have been difficult to maintain across generations. This brings us back to the origin of humans. The body that became tall was also a body with an unusually demanding brain and a long childhood. These two features made energy even more central. The brain uses a large share of the body's resources, especially during development. A child growing into a human adult is therefore not simply building longer bones. The child is also developing memory, movement, language capacity, social understanding, and the skills needed to live inside a group. Food made that long development possible, but food itself was often made possible by the group. Sharing matters here. A young child cannot gather enough for itself. An injured adult may need others. A caregiver feeding a child depends on resources brought by more than one pair of hands. In this way, calories become social before they become height. The growth of the skeleton is tied to cooperation, not just appetite. A tall human body remembers landscapes, but it also remembers meals that arrive from others. It remembers tools touching food before teeth did. It remembers children fed before they could provide for themselves. Height, then, was not simply selected in the bones. It was sustained by a food world large enough, flexible enough, and shared enough to let slow growth continue. A growing human body needs more than food in a general sense. It needs usable energy, and it needs that energy to arrive often enough for growth to continue. This is why the kinds of food available to early humans matter so deeply. A tall body cannot be built only from rare abundance. It needs repeated support through ordinary days. Bones need minerals and protein. Muscles need fuel and repair. The immune system needs resources to fight infection. The brain, especially in a human child, continues to demand a large share of energy while the body is also trying to lengthen. When these demands meet a poor diet, growth may slow. When they meet a richer and more reliable food world, a larger body becomes more possible. Animal foods may have helped because they can provide dense energy and important nutrients, but the human story should not be reduced to meat alone. Plant foods remained essential in many environments. Underground storage organs, fruits, nuts, seeds, leaves, and other gathered resources could all support survival depending on place and season. The important change was not one single food, but the widening of what the body could use. Early humans and their relatives became increasingly skilled at finding, processing, sharing, and combining foods from many sources. A varied diet can buffer a group when one resource disappears. If fruit is scarce, underground foods may still exist. If hunting fails, gathered plants may matter more. If one area dries, memory of another area can keep the group alive. This flexibility matters for height, because growth depends on continuity. The child's body cannot pause for years and then recover every lost possibility. It responds to the conditions of childhood as they unfold. A food system that is flexible enough to reduce long periods of shortage can allow more children to approach their potential size. Tools change this relationship between food and body. A sharp edge can open flesh, cut tough material, scrape hides, or separate useful tissue from bone. A stone used for pounding can break hard seeds or soften plant matter. A digging stick can bring hidden foods out of the ground. These actions may look small, but they change how much energy the body can gain from the world. Teeth and jaws alone have limits. Hands, tools, and shared knowledge extend the digestive system outward into the environment. Before food enters the mouth, it may already have been altered by cutting, crushing, peeling, breaking, or later by heat. Cooking is especially important in the broader human story because it can make many foods easier to chew and digest, and it can reduce some dangers in food. The exact timing of regular cooking is still discussed, so it is better not to attach the whole story of height to one fixed moment. Still, the general principle is strong. Processing food can increase the usable energy available to a body. For a lineage with long childhoods, demanding brains, and potentially taller adults, that matters. Energy saved in chewing and digestion can be used elsewhere. Softer food can be eaten by children, older adults, or injured members of the group more easily. Food made more usable by tools or fire can support bodies that would otherwise face sharper limits. This connects directly to the origin of humans because our bodies did not evolve as isolated machines. They evolved with hands, memory, cooperation, and learned techniques. A tool body is not only the result of what the stomach received, it is also the result of what hands did before the stomach began its work. Sharing may have been just as important as processing. A young child cannot find enough food alone. A caregiver cannot always gather, protect, and feed without help. A group that shares food spreads risk across bodies. One person's success can support another person's growth. This does not mean ancient groups were always generous or peaceful. It only means that human survival increasingly depended on social arrangements in which food could move between individuals. When food moves through a group, childhood becomes more survivable. When childhood becomes more survivable, slow growth becomes less dangerous. When slow growth can continue, height has time to appear. The tall human body therefore points to a food world that became richer not only because nature offered calories, but because humans learned to unlock them together. Meat, plants, tools, cooking, memory, and sharing all belong to the same quiet pattern. They helped create the conditions in which a costly body could grow long enough to stand fully upright, look across the ground, and carry the history of many meals inside its bones. A tall body is not fed by one meal, one tool, or one lucky day. It is fed by a whole food system, repeated across childhood and carried across generations. This is why height belongs to ecology as much as anatomy. Ecology here does not mean only plants, animals, weather, and water. It also means the way a living group fits into those things. Early humans and their relatives did not simply take food from the world in a fixed way. They learned where foods appeared, when they disappeared, which materials could be cracked or cut, which places held water, and which routes made return possible. The body that eventually became taller was surrounded by this wider web of knowledge and behavior. A long-legged adult may have walked farther to find food, but that food then had to come back into the group, into the hands of children, caregivers, injured adults, and others who could not always provide for themselves. In this sense, human height was never only private. It was grown inside a shared food landscape. A child's bones lengthen quietly, but the support for that length may come from many sources: gathered plants, animal foods, processed roots, broken seeds, marrow, cooked meals in later human life, remembered places, and the repeated labour of others. No single element explains everything. The safer and more honest picture is a network. More varied food gave bodies more chances to survive shortage. Tools helped unlock resources that teeth alone might not use well. Fire, when it became a regular part of life, made some foods easier to chew and digest. Sharing moved energy from those who had it to those who needed it. Together, these changes could make slow growth less fragile. This matters because the human body was carrying several expensive traits at once. A larger brain demanded energy. A long childhood demanded patience and care. A taller frame demanded years of steady construction. If any one of these costs had stood alone, it might have been difficult enough. Together, they required a way of life that could keep supporting the unfinished body. The origin of human height therefore points toward an important truth. Our bodies were shaped not only by what we could do as adults, but by what our groups could provide before adulthood. The adult height seen at the end of growth is only the visible result. Behind it are seasons of food, illness resisted, hunger survived, and care given before the child could repay any of it. This is why the history of human height cannot be separated from the history of human dependence. A tall body is possible only after many needs have been met at the right time. It needs enough food during early growth, enough health to use that food, enough protection to survive weakness, and enough social support to carry the child through years when the body is still forming. Food is the bridge between the outer world and the skeleton. Climate may favour a body that releases heat. Distance may favour longer legs. Upright walking may allow the legs to become central. But without energy, all of those possibilities remain unfinished. Bones cannot grow an idea. They grow from nourishment. Seen this way, human height becomes a quiet record of an increasingly complex life. It remembers landscapes that offered many kinds of food, hands that changed food before it was eaten, and groups that allowed energy to reach those still growing. It also reminds us that height is not a simple sign of superiority. When food systems collapse, disease spreads, or childhood becomes harsh, bodies can become smaller. Human height rises and falls with conditions. It is a living measure of the world a child grows inside. So the answer continues to widen. Humans became tall not because one force pushed us upward, but because walking, heat, tools, food, sharing, and care slowly formed a world where a costly body could keep growing. The next clue lies in that long childhood itself. Human height is not finished at birth. It is not even close. A newborn human enters the world with a body that is alive, sensitive, and full of possibility, but still far from the adult form it may one day reach. The bones are short, the muscles are weak, the brain is growing rapidly, the hands cannot yet work for food, and the legs cannot yet carry the body through a landscape. This long beginning is one of the most important facts about being human. We grow slowly, we depend deeply, we spend many years becoming capable of the very life our bodies are shaped to live. For the question of height, that slow growth is not a small detail. It is central. A tall adult body requires time, and human childhood provides that time, but only at a cost. The longer a child remains dependent, the longer others must protect, feed, teach, and carry that child through danger. In many animals, the young reach independence faster, their bodies mature more quickly, and the risky period of helplessness is shorter. Humans took another path. Our bodies grow through a long sequence: infancy, childhood, later growth, and adolescence, each with its own demands. A great deal of height is added long after birth, and the final adult body depends on what happens across those years. Enough food, fewer severe illnesses, rest, safety, and care all matter. Genes help guide growth, but genes do not build bones without the world. The origin of human height therefore leads us back to the origin of human childhood. Our ancestors became creatures whose young needed unusual amounts of time before they could fully survive on their own. That may seem like a weakness, and in one sense it is. A slow-growing child is vulnerable. A child who needs years of feeding creates pressure on caregivers. A group with many dependent young must solve problems that a faster-growing species does not face in the same way. Yet this long childhood also opens space for the human body and mind to develop together. The brain could keep learning while the body was still growing. Movement, memory, tool use, social understanding, language capacity, and knowledge of place could be shaped gradually. The young body did not simply wait to become adult. It learned the world while becoming large enough to move through it. This connection between growth and learning is one reason height cannot be treated as a simple adult trait. The tall person at the end of growth is the result of a long, protected process. Without that process, the height would never arrive. In early human communities, a child's future body depended on more than the mother alone. Care could involve fathers, relatives, older siblings, and other group members, though the exact patterns would have varied. Food shared across a group could support a child when direct gathering was impossible. Protection could reduce the dangers of weakness. Teaching could turn a slow childhood into a long preparation for adult life. In this way, human height belongs to a social species. It is not only a measurement of bones, it is a sign that a young body was allowed to remain unfinished for many years. The fossil record can show bones, teeth, and growth patterns, but it cannot preserve every act of care that made growth possible. Still, the human life history tells a clear story. We are slow to mature compared with many mammals, and that slowness is tied to the kind of bodies and minds we have. A tall body, then, is not rushed into existence. It is accumulated. It is built through seasons of dependence. It is shaped by the patience of biology and the support of others. Before humans could become tall adults, they first had to become children who could afford to grow slowly. That slow permission became part of our height. A long childhood gives the human body something rare in nature: time to remain unfinished. This may sound like a disadvantage, because an unfinished body is weak. It cannot feed itself well. It cannot defend itself well. It cannot travel far without help. Yet within that weakness is the space where human growth becomes different. A body that matures too quickly must complete its shape early. A human body grows in a more extended rhythm. It adds height over many years. While the brain is still learning, the hands are still becoming skilled, and the young person is still absorbing the rules of living inside a group. Height, in this sense, is not only a biological measurement, it is part of a long developmental schedule. The skeleton grows while the child learns where food comes from, how tools are used, who can be trusted when danger is near, and how the group moves through the landscape. The body is becoming larger at the same time that the mind is becoming more capable. This is one reason the origin of human height cannot be separated from the origin of human learning. Our ancestors did not simply grow tall and then begin to live human lives. They grew inside those lives, gradually shaped by them. A child with years of dependence can learn complex behaviors before being forced fully into adult survival. That long preparation has costs, but it also allows skills to accumulate. In a species that depends on memory, cooperation, tools, food sharing, and social signals, a slow childhood can become more than a delay. It can become a way of building a body and a mind together. Human bodies do not add height at one constant speed from birth to adulthood. Growth moves through phases, and each phase can be affected by nutrition, disease, stress, and care. If childhood is supported, the body may continue growing toward its potential. If childhood is repeatedly interrupted by hunger or illness, the body may become smaller than it might have been under better conditions. This is not a judgment on the person. It is a record of the environment around the child. Ancient bodies would have carried these records too. A bone is not only inherited shape, it is also lived experience. The long human childhood made adult height sensitive to the conditions of early life. That sensitivity helps explain why height varies so much across populations and across history. It is not fixed by one cause. It responds to the world in which a child grows. Near the beginning of the human lineage, this meant that height could only become common where slow growth was survivable often enough. A tall adult body had to pass through many fragile years. It had to pass through weaning, infections, injury, food shortages, and the dangers of movement. It had to be fed when it was not yet useful in an adult way. This is where human social life becomes inseparable from height. A long childhood can work only when care is extended. The child may receive food from a mother, but also from other adults, older children, kin, and group members, in ways that likely varied across communities and environments. The exact details are not preserved in fossils, so we should not pretend to know every arrangement. But the broad biological fact remains: human children need support for a long time. The body that grows tall is therefore supported by relationships before it stands as an independent adult. A slow-growing child is a burden in the short term, but across generations, that same slowness may have allowed more learning, more flexible behavior, and a body capable of endurance and range. Height was not the only result. It was one visible thread in a larger pattern of delayed maturity. The human form became possible because growth was not rushed. Bones could lengthen, muscles could strengthen, skills could develop, and the group could carry the young through the years before they could carry themselves. A tall human body may seem to belong to one person, but it is never made by one person alone. It is grown inside care. The bones lengthen in the child, yet the conditions that allow those bones to lengthen often come from many hands, many decisions, and many ordinary acts of support. A young human cannot gather enough food alone. It cannot protect itself from every danger. It cannot understand seasons, routes, tools, social rules, or the hidden signs of illness without learning from others. For years, the body is becoming larger while the child remains dependent. Height, therefore, is not only a property of the skeleton, it is also a property of a social world that can keep a slow-growing body alive long enough for growth to finish. In the deep past, long childhood would have been both precious and difficult. A child who needs care for many years creates demands on adults. Food must be found, processed, and shared. Movement must be planned around those who cannot move quickly. Sickness must be endured without modern medicine. Danger must be watched for by more than the child. Such care would not always have succeeded. Many children in ancient environments likely faced hunger, infection, injury, and loss. It would be false to make the past gentle, but it would also be false to imagine human evolution without care. The very shape of our life history suggests that support became a central part of survival. A species with slow-growing young can continue only if enough of those young are carried through their vulnerable years. The origin of human height belongs to that larger pattern. Long legs and larger bodies may help adults travel, endure heat, or search across distance, but those adult advantages cannot appear unless children are fed before they are useful in the same way. A child's height is built from meals received before the child can repay them. It is built from rest made possible by safety. It is built from knowledge passed down before the child understands why it matters. Over many generations, groups that could support dependent young created the conditions for bodies that matured slowly and grew for a long time. The skeleton carries a record of that arrangement. Not a perfect record, not a complete story, but a trace. When growth continues well, bone can extend. When growth is repeatedly interrupted, the body may remain smaller. The difference is not just genetic. It is historical, environmental, and social. A tall adult is, in one sense, a survivor of childhood conditions that were good enough, often enough, for growth to continue. That idea keeps human height humble. It prevents us from treating tallness as a private achievement or a simple sign of strength. In reality, height can reflect nutrition, health, disease exposure, sanitation, workload, stress, and care. In ancient human life, it also reflected whether the group could turn food from the landscape into nourishment for those who still depended on others. The body of a child was linked to the memory of places, the skill of hands, the patience of caregivers, and the protection of the group. Human height, then, is a quiet social fossil inside living anatomy. It reminds us that our bodies were shaped not only by competition, but also by dependence. Not only by walking far, but by being carried before we could walk far. Not only by finding food, but by receiving food. The question of why humans became so tall cannot be answered only by looking at adults standing under the sun. We must also look at the child near the fire, near the shelter, near the arms of others, still unfinished, still growing, still becoming the body that evolution would later measure. Before height became an adult trait, it It was a childhood protected through time. Height feels easy to measure, but it is not easy to explain. A line on a wall can tell how tall a person is, yet it cannot tell why the body stopped there. Human height is guided by many forces working together. Some come from inheritance, some come from food, some come from illness, hormones, childhood stress, sleep, and the timing of growth. No single switch inside the body makes a person tall. No single gene writes the whole answer. Instead, height is shaped by a wide network of biological instructions and life conditions, each one adding a small part to the final adult form. This is why the question of human tallness must slow down again. After looking at walking, heat, food, and childhood, we have to look inside the body itself, but carefully. Genes matter deeply, yet genes do not act alone. They provide tendencies, limits, and possibilities. They influence how bones respond to growth signals, how the body uses nutrients, how puberty begins, and how long growth plates remain active. But those inherited tendencies need a living environment in order to appear. A child may inherit the potential for a tall body, but repeated hunger, disease, or severe stress can keep that potential from being reached. Another child may inherit a more moderate growth pattern, and even under good conditions may not become very tall. Height is therefore not a pure message from ancestry. It is a result of ancestry meeting the world. Hormones are part of that meeting. Growth hormone, thyroid hormones, insulin-like growth factors, and sex hormones all help regulate how the body grows. They do not work like simple commands. They interact with nutrition, age, health, and development. During childhood, growth must remain active for years. During adolescence, changes in hormones can speed growth and then gradually bring it to an end as growth plates close. This timing matters. If the body matures earlier, the period of growth may end sooner. If growth continues longer under healthy conditions, more height may be added. But again, the body is not free to grow without limits. Bones must remain strong enough to carry weight. The heart and lungs must serve a larger frame. The joints must handle force. The brain and organs must receive enough energy while the skeleton lengthens. A taller body is a coordinated system, not only longer bones. This connects back to the origin of humans because evolution works on whole living bodies, not isolated traits. Longer legs may help movement. A taller, narrower shape may help with heat. A long childhood may allow extended growth. But all of these traits have to function together within one body that eats, sweats, heals, reproduces, and survives. If height creates too much cost, it will not remain useful. If it fits with the body's other systems and with the environment, it may become part of a population's pattern. This is why height differs among individuals and populations without needing a single explanation. Genetic variation is real, but so are differences in childhood nutrition, disease exposure, workload, climate, and social conditions. Even in modern life, where many people have better food and medicine than most ancient communities, height still reflects both inherited biology and early environment. In the deep past, that interaction would have been even more visible. A body growing through dry seasons, infections, injuries, and uncertain food could not express its inherited possibilities in a clean way. So when we ask why humans became so tall, biology gives us a layered answer. Height is possible because the body carries genetic instructions for growth. Height is limited because growth must obey energy, hormones, health, and structure. Height changes across history because children grow inside different worlds. There is no need to imagine one hidden cause. Human tallness emerged from many small biological pathways, meeting many external pressures. The body rose slowly, not as a design drawn in advance, but as a living compromise held together by genes, hormones, food, care, and time. Genes give height its deep biological framework, but they do not build the body by themselves. A child inherits many genetic variations from parents, and many of these variations can influence growth in small ways. Some affect the length of bones. Some affect how cells respond to growth signals. Some affect the timing of puberty, the strength of the skeleton, the use of nutrients, or the balance of hormones. But height is not controlled by one simple instruction. It is influenced by many parts of the genome working together, each with a modest effect. This is why children often resemble their families in height, but do not become exact copies of anyone. The inherited pattern sets a range of possibility. The lived environment decides how much of that possibility can be reached. Hormones help turn possibility into growth. Growth hormone is one important signal, but it is only part of a larger system. Thyroid hormones help regulate metabolism and development. Insulin and related growth factors help connect nutrition to tissue building. Sex hormones, especially during adolescence, help create the familiar period of faster growth and then help bring growth to an end when the growth plates of the bones close. These signals must arrive in balance. Too little of an important hormone can slow growth. Too much, or badly timed signals, can also disturb the body's rhythm. The body is not trying to become as tall as possible. It is trying to survive, develop, and remain coordinated. Bones must lengthen at a pace the muscles, tendons, joints, heart, lungs, and blood supply can support. This is why height is not merely a vertical ambition of the skeleton. It is the outcome of the whole body staying organized through years of change. Nutrition is the material side of that organization. Hormones can tell tissues to grow, but they cannot create bone and muscle without resources. Protein, energy, minerals, and many micronutrients matter because the growing body is constantly building and repairing itself. If food is insufficient, the body may conserve energy. Growth can slow because survival is more urgent than length. This would have been especially important in the early human story, where food was never guaranteed in the modern sense. A child growing in a harsh season might not follow the same path as a child growing in a more stable season. A group with better access to varied foods could support growth more reliably than a group facing repeated shortage. This does not mean ancient people thought about height as a goal. It means their bodies responded to what the world allowed. Disease is another hidden force. Infection can take energy away from growth. The immune system is not separate from the rest of the body. When it fights illness, it uses resources that might otherwise help build tissue. Repeated infections can reduce appetite, interrupt digestion, weaken the body, and slow development. Parasites, chronic inflammation, and early childhood illness can all leave marks on growth, even if the genes for height remain unchanged. This matters because human height has always been sensitive to the conditions of childhood. In deep time, children grew without modern sanitation, antibiotics, vaccines, or stable medical care. Their bodies had to divide energy between growing and surviving. A taller adult form could only become common where enough children passed through these pressures with sufficient food, health, and care. The origin of human height therefore belongs to the meeting point of inheritance and circumstance. Genes carried possibilities from one generation to the next. Hormones coordinated the timing and speed of growth. Nutrition supplied the materials. Disease and stress could take those materials away. Care could buffer danger by feeding, protecting, and supporting the child through vulnerable years. None of these forces alone explains why humans became tall. Together, they show why height is both biological and historical. It is biological because it depends on inherited systems inside the body. It is historical because those systems unfold inside real environments, real childhoods, and real communities. The human skeleton grew upward only when the inner signals of growth met enough outer support to keep going. It can be tempting to say that humans were designed to be tall, as if the body were planned in advance and then built toward a clear goal. But that is not how evolution works. Evolution does not look ahead. It does not decide that a future species should stand higher, walk farther, or grow longer legs. It works through variation, survival, reproduction, and time. Bodies differ. Some differences help more in one environment than in another. Some differences bring costs that are too heavy. Some survive only when other traits and social conditions make them possible. Human height belongs to this slow process. It was not a finished design waiting to appear. It was a result of many pressures meeting many limits. Upright walking made longer legs more meaningful. Wider landscapes made efficient movement more useful. Heat made body shape and sweating important. Food made growth possible. Childhood gave growth time. Care protected that time. Genes and hormones coordinated the inner process, but they did not remove the outer costs. A tall body could continue only where these pieces worked together often enough across generations. This is why height should be understood as a compromise rather than an achievement. A very large body can need too much food. A very small body may not move or regulate heat in the same way. A body that grows too slowly may remain vulnerable for too long unless others can help. A body that matures too quickly may lose time for learning and growth. Evolution does not choose perfection. It keeps what can survive under real conditions. The human form, with its long legs, upright posture, demanding brain and slow childhood, is one such compromise. It solved some problems while creating others. This connects back to the beginning of the human story. Our ancestors did not move through a world that rewarded height in every place and every season. Some environments may have favoured smaller bodies. Some periods of stress may have reduced growth. Some populations later became taller or shorter depending on food, disease, climate and history. Even today, height differs among people not because some bodies are closer to an ideal, but because growth is shaped by both inheritance and lived conditions. A child's final height can reflect genes, but also nutrition, illness, safety, workload, and the broader life of a community. This is why it is misleading to turn height into a ranking of human worth. It is a biological outcome, not a moral measure. In the deep past, the same was true. A shorter ancestor was not less human, less adapted, or less important. A smaller body could be exactly what a particular environment allowed or favoured. A taller body became meaningful only where its advantages could repay its costs. The safest way to speak about human height is therefore not to say that we were made tall, but to say that our lineage passed through conditions in which taller, longer-legged bodies became possible and useful in certain ways. Those bodies carried the memory of walking, heat, food, care and time. They were shaped by selection but also constrained by development. They were guided by genes but completed by childhood. They were useful as adults but expensive before adulthood. This layered view keeps the story honest. It also makes the human body more interesting. Height is not a simple answer. It is a trace left by many questions acting together. How to move, how to cool, how to feed, how to grow, how to protect the young, and how to survive long enough for the next generation to begin. The human body rose through those questions, not above them. Human height is not the same everywhere, and it has never been the same everywhere. Some populations are, on average, taller. Others are, on average, shorter. Even inside one family, siblings can grow to different heights. This variation is not a mistake in the human story. It is one of the clearest signs that height is shaped by many forces at once. The body grows from inherited biology, but it grows inside a particular world. That world has climate, food, disease, migration, work, childhood care and history. When these conditions differ, bodies can differ too. A tall body in one region and a shorter body in another do not represent a simple ladder of progress. They represent different relationships between genes and environments. Climate is one influence, though it must be handled carefully. In warm regions, longer and more linear body proportions can help release heat. In colder regions, shorter and more compact proportions can help conserve heat. This broad pattern is often discussed in biology, but it is not a strict rule for every person or every group. Real human populations have moved, mixed, adapted, and changed through history. Climate can shape body proportions over long periods, but it is never the only explanation. Food matters strongly. Children who grow with enough nutrition, fewer severe shortages, and better health may reach more of their inherited growth potential. Children who grow through repeated hunger, illness, or heavy stress may become shorter than they might have been under different conditions. This is not about personal value. It is about development. The skeleton records the conditions of childhood in ways the child did not choose. When we look back toward the origin of humans, this point becomes essential. Our ancestors did not evolve in one uniform environment. They lived through changing climates and shifting landscapes. Some groups moved through open spaces, some remained closer to wooded or mixed habitats, and later human populations spread into deserts, mountains, islands, forests, plains, and cold northern regions. Each place placed different demands on movement, heat, food, and survival. A body that worked well in one setting was not automatically best in another. Disease also shapes height. A child repeatedly fighting infection may use energy for survival instead of growth. Poor sanitation, parasites, and chronic illness can quietly reduce adult stature across a population, even when food seems present. This helps explain why height can change over time within the same broad ancestry. If living conditions improve for several generations, average height may increase. If food quality declines or disease becomes more common, average height may fall. This has happened at different times in human history, especially around major changes in diet, settlement, crowding, labor, and public health. Population history adds another layer. Groups carry different inherited patterns because of ancestry, migration, isolation, and mixing. But inherited differences cannot be understood apart from environment. Genes provide possibilities. Childhood conditions decide how those possibilities unfold. A population may carry a tendency toward taller or shorter average stature, but nutrition, disease, and social conditions can still shift the final outcome. That is why height is both biological and historical. It is written in DNA, but also rewritten by fields, kitchens, water sources, illnesses, migrations, and the long care of children. The human body became tall in some lineages and stayed smaller in others because human life was never one single experiment. It was many lives unfolding in many worlds. If the central question is why humans became so tall, then variation gives a quiet warning. Humans did not become tall in the same way, to the same degree, everywhere. Tallness was one possible result of the human body's flexibility. Shorter bodies were not failures of evolution. They were also human answers to real conditions. The deeper lesson is that height is not a fixed monument. It is a living record of climate, nourishment, health, movement, ancestry, and childhood, all meeting inside the growing body. Differences in height can easily be misunderstood if they are taken out of context. A number looks simple. One body is taller, another body is shorter. One population may have a higher average, another may have a lower average, but the meaning behind those numbers is not simple at all. Height is not a measure of worth, intelligence, strength of character, or human importance. It is not a ranking of peoples. It is the visible end of many hidden processes that begin before birth and continue through childhood. Genes, food, disease, climate, stress, work, care, and history all meet inside the growing body. To compare height without remembering those forces is to mistake the shadow for the object. A shorter average stature in one group does not mean that group is less developed in any human sense. It may reflect long adaptation to climate, repeated childhood illness, historical poverty, food limitations, population history, or a body shape suited to a particular environment. A taller average stature in another group does not mean superiority. It may reflect inherited tendencies, improved childhood nutrition, lower disease burden, or recent living conditions that allow more growth. The body records what it has been given and what it has endured. It does not make moral judgments. This matters especially when speaking about human origins, because our lineage was never a single uniform body moving through a single uniform world. Early humans and later human populations lived in many environments, and different environments placed different pressures on growth. In warm regions, certain long and narrow body shapes may help with heat loss. In colder regions, more compact proportions may help conserve heat. In places with reliable food, children may grow closer to their inherited potential. In places with repeated shortage or infection, growth may be limited. These patterns do not create a ladder. They create a map of relationships between bodies and worlds. A body can be well suited to its own setting without resembling another body from another setting. This is a quiet but important lesson. Evolution does not produce one final human shape and then grade everyone against it. It produces variation, and variation is one of the ways life survives change. The origin of human height must therefore be told without turning tallness into destiny. Long legs and greater stature may have helped some ancestral populations move, release heat, and search across broader landscapes. But that does not mean every human group had to become taller, or that shorter bodies were somehow incomplete. A smaller body can need less food. It can conserve heat differently. It can mature within different ecological limits. It can be a practical answer to a real world. Even within the same population, individuals vary because growth is sensitive to childhood. Two people can inherit different possibilities, but they can also grow through different conditions. One may have had better nutrition, fewer infections, less stress, or more time for recovery. Another may have faced illness or shortage that quietly redirected energy away from growth. The final height tells part of a life story, but never the whole story. It should be read with humility. History also warns us against simple conclusions. Average height has risen and fallen in different societies depending on diet, disease, crowding, inequality, sanitation, and childcare. Civilizations did not always make bodies taller. Progress in tools, buildings, or social complexity did not automatically mean better childhood health. Sometimes settled life brought new burdens, including narrower diets and more infectious disease. At other times, improvements in food, medicine, and living conditions allowed children to grow taller within only a few generations. These changes show how flexible human height is. It can respond quickly to the world children grow inside. That flexibility should make us careful, not judgmental. If height is shaped by so many conditions, then it cannot be used as a simple label for human groups. The honest view is gentler and more accurate. Every human body is a record of ancestry meeting circumstance. Tallness and shortness are both human outcomes. They carry traces of climate, migration, nourishment, illness, care, and time. The question is not which body is better. The deeper question is what each body has passed through to become itself. Height can look like something that belongs only to the body standing in front of us. But when we look more slowly, it reaches backward. It reaches into childhood, into food, into illness, into climate, into migration, and into the lives of parents and grandparents. A person's height is visible in the present, but it often carries traces of conditions that began long before that person could choose anything. This is why height should be understood as a record, not a judgment. It records how growth unfolded. It records whether the body had enough energy to build bone and muscle. It records whether disease repeatedly took energy away. It records whether the child had enough care, enough rest, and enough protection to keep growing through vulnerable years. Across populations, it also records larger histories, movement into new climates, changes in food systems, periods of hardship, recovery after hardship, and the slow influence of ancestry. None of this makes height a measure of human value. It makes height a quiet meeting place between biology and history. This matters because the human body did not become tall in one universal way. Our ancestors and later human populations lived in different landscapes. Some environments made long-distance walking and heat release more useful. Other environments placed different pressures on conserving energy or warmth. Some communities had access to varied foods. Others faced repeated shortages. Some children grew in settings with heavy disease burdens. Others grew when disease pressure was lower. These differences could shape adult height without saying anything about the worth of the people themselves. A shorter body can be a practical outcome of environment, ancestry, and development. A taller body can be the same. Both are fully human. Both belong to the same broad story of adaptation and constraint. The origin of human height becomes clearer when we stop asking which body is superior and begin asking what conditions allowed each body to grow. A tall adult may carry the memory of a childhood with enough nourishment, fewer interruptions from illness, and a life history that permitted long growth. A shorter adult may carry the memory of a different genetic background, a different climate, or a childhood shaped by stress, disease, or limited food. These are not moral meanings. They are biological and historical meanings. The body is not making an argument. It is showing a result. Even then, the result is incomplete. Height does not reveal courage, wisdom, kindness, endurance, memory, skill, or dignity. It reveals one visible outcome among many invisible ones. Human history has often made the mistake of turning visible differences into false hierarchies. Height can be pulled into that mistake if we are careless, but a more honest view does the opposite. It uses height to remind us how dependent every human body is on the world around it. No child grows alone. No skeleton lengthens outside food, health, care, and time. No population carries height without carrying history. In that sense, height is humbling. It shows that the body is not separate from the conditions that surround it. It shows that generations leave marks not only in stories and tools, but also in growth. A population may become taller when children live through better nutrition and lower disease. It may become shorter when food narrows, illness spreads, or work becomes too harsh, too early. These shifts can happen without any change in human worth, ability, or dignity. They are changes in conditions, expressed through bodies. So when we return to the question of why humans became so tall, we should remember that tallness was never a single human destiny. It was one possible outcome of upright walking, wider landscapes, heat, food, long childhood, genes, and care. It was shaped differently in different places. It rose and fell through history. It carried the marks of environments and generations. A human body is not a ruler for ranking people. It is a living archive of what life has allowed, limited, and carried forward. When humans began to farm, the story of height did not simply move upward. This can feel surprising, because agriculture is often imagined as progress in a straight line. Fields, villages, stored grain, pottery, animals, houses, and later cities can make the past look more secure than the life of mobile foragers. But the body does not measure progress by buildings or storage alone. It measures the food that reaches a child, the infections that enter the body, the labor demanded each day, and the years of growth that remain possible. In many places, the shift toward farming brought new stability, but also new limits. Diets could become narrower, communities could become more crowded. Diseases could spread more easily among people living close together, sometimes near domesticated animals and waste. Work could become repetitive and heavy. The result was not the same everywhere, but in several archaeological records, average stature appears to decline after the adoption of agriculture, at least for some populations and periods. This does not mean farming was a mistake in a simple sense. It means that cultural change and biological well-being do not always rise together. A society can become more complex while many bodies inside it face new stress. This is important for the question of why humans became tall, because it shows that height is reversible. It can be supported by one way of life and limited by another. The long human body, shaped earlier by walking, heat, food, variety, childhood, and care, still depended on conditions in childhood. If those conditions changed, growth could change too. Farming often made calories more predictable, especially through staple crops. But predictable calories are not the same as a complete diet. A community that depends heavily on one or a few staple foods may survive larger numbers of people, yet children may receive less variety and nutrients than earlier foraging groups had in some environments. Grain can feed many mouths, but a grain-heavy diet may not always provide everything a growing body needs in the right balance. At the same time, settled communities can allow infections to circulate more continuously. A child repeatedly fighting illness may lose appetite, absorb nutrients less well, and spend energy on immune defense rather than growth. The skeleton may then carry the quiet marks of this struggle. The origin of human height teaches us that long growth requires more than survival. It requires enough health and nourishment over time. Early farming could keep more people alive in some contexts, while still reducing the average height or health of many individuals. This is not a contradiction. It is one of the deep trade-offs in human history. Agriculture changed the relationship between humans and land. It allowed food to be produced in concentrated places. It allowed storage, planning, population growth, inheritance, and settlement. But it also tied people to fields, harvest cycles, crop failures, social obligations, and new forms of inequality. Some people may have had better access to food than others. Some children may have grown with more security, while others bore the cost of labor, shortage, or disease. Height, in such a world, became not only a biological record, but also a social record. It could reflect who had enough food, who carried heavy work, who survived infections, and who grew during years of scarcity. This is why farming complicates the idea that humans became steadily taller as history advanced. The body does not follow the same timeline as tools or monuments. A village may grow larger while children grow shorter. A field may produce more total calories while individual diets become less diverse. A city may rise while disease and crowding make childhood more difficult. The human skeleton, quiet under the soil, reminds us that progress has always had a bodily cost. If height tells a story, farming teaches that the story can bend downward. Agriculture did not make the human body smaller by one single path. It changed many conditions at once, and several of those changes could press against growth. The first was diet. Many farming communities relied heavily on a few staple crops. These foods could feed more people and could be stored against the future, which was a major change in human history. But a diet built around a narrow set of crops could also reduce nutritional variety. A child may receive enough calories to survive, yet still lack the full range of nutrients needed for strong growth. Bones lengthen best when energy, protein, minerals, and general health arrive together over many years. If one part is missing too often, the body may continue living but reduce its investment in height. This is one reason some early farming populations appear shorter than earlier or neighbouring foraging groups. The issue was not that farming food had no value, it was that survival calories and growth conditions are not the same thing. The origin of human height shows why this matters. Our taller form required long childhood, repeated nourishment, and enough health to keep growing. When a food system became more predictable but less varied, it could support larger communities while quietly limiting the bodies of children inside them. The second pressure was disease. Settled life brought people, waste, stored food, and animals into closer contact. Crowding can allow infections to circulate more easily. Stored grain can attract pests. Water sources can become contaminated. Domesticated animals can be part of new disease environments. These conditions would not have been identical everywhere, but they created risks that mobile groups might have faced differently. For a growing child, repeated infection is not a small interruption. Fever, diarrhea, parasites, and chronic inflammation can reduce appetite, interfere with nutrient absorption, and force the body to spend energy on defense. The immune system protects life, but it uses resources. Energy spent fighting disease is energy not fully available for bone growth. A child may survive, but the adult skeleton may later show that growth was interrupted. Archaeological remains cannot tell every personal story, yet patterns in bones and teeth can reveal stress during development. This is why height becomes a quiet archive of public health long before public health had a name. The third pressure was labor. Farming can demand repeated heavy work: clearing land, planting, weeding, harvesting, grinding grain, carrying water, caring for animals, and maintaining houses and fields. Work is not harmful by itself, but heavy labor combined with limited diet and disease can strain a growing body. Children may have contributed to tasks early in life, and adults may have carried workloads that affected pregnancy, care, and food distribution. The body is always balancing its resources. If energy is used for work, illness, and survival, less may remain for growth. This connects agriculture to height in a direct but careful way. Farming did not simply make humans weaker or shorter everywhere. It created new trade-offs. More food could be produced overall. More people could live in one place. Communities could grow, store, inherit, and build. But the individual child might face a narrower diet, more infection, and more labor than before. These pressures could limit stature even as society became more organized. Human height, therefore, challenges a simple story of progress. The body asks different questions from civilization. It asks whether food was varied enough, whether water was clean enough, whether disease was too frequent, whether childhood had enough rest, and whether growth could continue without repeated interruption. In many farming worlds, the answer was mixed. Agriculture gave humans new power over land, but it also placed new demands on the body. The skeleton kept the record with quiet honesty. Those demands did not erase human adaptability, but they remind us that a field can feed a village while narrowing the growth of a child. The history of height teaches a quiet lesson about civilization. Human societies can become more organized, more settled, and more powerful without making every body inside them healthier. A field can produce food for many people, yet the children living beside that field may not always grow taller. A village can store grain, but stored grain does not guarantee a varied diet. A city can rise above the ground, while disease moves through crowded homes and narrow streets. A monument can survive for thousands of years, while the bodies that built it may have carried hunger, pain, and interrupted growth. This is why height is such an important clue. It does not obey our simple ideas of progress. It responds to childhood. It responds to food, illness, workload, rest, and care. When those conditions improve, bodies may grow taller. When those conditions worsen, bodies may become smaller, even if society appears more advanced from the outside. The move toward agriculture and settlement shows this clearly. Farming allowed larger populations, more permanent communities, storage, new tools, social roles, and eventually states and cities. These were enormous changes in human history. But the biological cost was not evenly distributed, and it was not always gentle. Some people may have gained more secure access to food, while others faced labor, inequality, disease, or poor nutrition. Some children may have survived because staple crops kept them alive, but their growth may still have been limited by repeated infection or narrow diets. Survival is not the same as full development. The human body can endure hardship and still carry the marks of that hardship in bone. This connects back to the origin of human tallness, because the tall human form was never guaranteed. It required long growth under conditions good enough to support it. Earlier pressures had helped make longer legs and taller bodies useful in certain environments, especially where walking, heat, distance, and endurance mattered. But once humans changed their way of life, the conditions of growth changed too. A body shaped by deep evolutionary history still had to pass through the daily realities of childhood. If the new world of fields and settlements gave less variety, more infection, or heavier labor, the body could answer by growing less. This does not mean agriculture only harmed humans. It means agriculture created a new bargain. It gave stability, but also dependence on crops. It gave storage, but also vulnerability to harvest failure. It gave settlement, but also crowding. It gave population growth, but sometimes at the cost of individual health. Height helps us see that bargain because it sits at the meeting point between society and biology. It is not only a natural trait, it is also a historical witness. A skeleton from a farming village may tell us that people survived, worked, and reproduced, but it may also show that their childhoods were stressed. Shorter stature, signs of disease, worn joints, and dental changes can all suggest that the rise of settled life carried bodily consequences. These clues do not make ancient people weak, they make them real. They remind us that the human past was not a simple climb from darkness to comfort. It was a series of adaptations, each solving some problems while creating others. Height rises and falls inside those trade-offs. The answer to why humans became so tall must therefore include the moments when humans became shorter. Without those reversals, the story would be too clean. The body became tall through walking, heat management, food energy, childhood, genes, and care. But history could still interrupt growth. Civilization did not erase biology. It placed biology into new conditions. The quiet truth is that human height has always listened more closely to the life of children than to the pride of societies. Stone walls, fields, and cities may tell one story of achievement. Bones tell another story, slower and more honest, about whether growing bodies had enough to become what they could have been. In the modern world, many human populations have become taller within only a few generations. This change can feel sudden when compared with the long pace of evolution. Bones that once seemed limited by deep ancestry began to lengthen more fully in children born under better conditions. But this recent rise in height is not best understood as a rapid transformation of human genes. Genes do not usually change so quickly across whole populations in such a short span of history. A better explanation is that more children, in more places, began to grow closer to the potential their bodies already carried. The difference came from the world around childhood. More reliable food, better public health, cleaner water, safer childbirth, vaccines, antibiotics, improved sanitation, and reduced childhood disease all helped protect growth. When fewer calories are lost to infection, when more nutrients are available, when children are sick less often, and when the body can rest and recover, growth can continue for longer and with fewer interruptions. Height rose because childhood changed. This is one of the clearest examples of how strongly the human body listens to its environment. A child's skeleton is not a fixed monument to ancestry. It is living tissue responding day by day to nourishment, illness, sleep, stress, and care. In earlier farming villages and crowded cities, children might have survived but still grown under heavy burdens. In more recent conditions, especially where nutrition and medicine improved, the same basic human body could express more of its growth capacity. This connects directly back to the origin of human tallness. The long human childhood made height possible, but it also made height vulnerable. A species that grows slowly can become tall only when the years of growth are supported. Modern improvements did not invent height from nothing. They removed some of the barriers that had often held growth back. Better diets provided protein, energy, minerals, and vitamins more consistently. Milk, grains, legumes, vegetables, meat, fish, eggs, and other foods entered different diets in different ways. But the broad pattern was that many children had more usable nourishment than before. Public health reduced the constant drain of infection. Clean water and sewage systems lowered exposure to diseases that once stole energy from growth. Medical care helped children survive illnesses that might once have weakened or killed them. Vaccination reduced the burden of certain infectious diseases. These changes did not affect every population equally, and they did not arrive everywhere at the same time. Inequality remained, and in many places still remains. But where childhood conditions improved across a society, average height often increased. That increase is a quiet reminder that human height is not only ancient, it is still responding. The body that was shaped by walking, heat, food, and care in deep time continues to answer the conditions of the present. A taller modern population does not prove that modern people are biologically superior to earlier people. It shows that more children may have had enough support to complete growth that past conditions often interrupted. This distinction is important. Ancient people were not shorter because they were lesser. Many were shorter because their childhood worlds were harder. More disease, less varied food, more physical stress, and fewer protections against infection. Modern height gains reveal the hidden cost of those older conditions. They also reveal the power of care at the scale of society. When a community improves food security, water, medicine, housing, and child health, the effects may appear in classrooms, homes, hospitals, and eventually in adult bodies. Height becomes a social record again, just as it was in the deep past. The recent rise in stature is therefore not a break from the human story. It is a continuation of the same principle. Human beings become tall when biology is given time, energy, and protection. The modern world has shown how quickly growth can respond when those supports become more stable. Yet it also reminds us that height has limits. Once a population approaches its biological range under good conditions, average height may slow or stop increasing. The body does not grow endlessly. It grows within boundaries set by genes, hormones, health, and structure. Modern height is not an escape from evolution. It is evolution's old body meeting new childhood conditions and growing as far as those conditions allow. Modern height rose where childhood became less interrupted. This is the central point. A child does not grow taller simply because a society becomes richer on paper, or because a country builds roads, factories, schools, and hospitals. The change must reach the growing body. It must arrive as food that can be eaten, water that does not carry as much disease, homes that protect rest, medical care that reduces severe illness, and adults who can keep children alive through vulnerable years. Height responds most strongly when improvements become ordinary enough to touch daily life. Better nutrition is one part of this change, but nutrition should not be imagined as only more food. More calories can prevent starvation, but growth also needs quality. Protein supports tissue building. Minerals help bones form. Vitamins support many processes that allow the body to use energy and repair itself. A child can survive on a limited diet and still not grow as fully as the body might under better conditions. In many modern populations, more varied diets gave children a stronger foundation for growth. Milk, eggs, meat, fish, legumes, vegetables, grains, and other foods mattered differently in different places. But the broad pattern was that more children received a steadier supply of usable nourishment. The body could spend less time protecting itself from shortage and more time building. This connects back to the biggest matting of human height, because the tall human form has always depended on long growth. The ancient child needed years of care to become a long-legged adult. The modern child still needs the same biological time, but in many places that time became safer. medicine changed the meaning of childhood illness. Before modern medical care, infections could take a heavy toll even when they did not kill. Fever, diarrhea, lung infections, parasites, and repeated inflammation could drain energy, reduce appetite, and slow growth. The child might survive, but survival could come with a smaller adult body. When vaccines reduced the burden of some diseases, when antibiotics treated bacterial infections, and when medical attention became more available, fewer children had to spend so much of their energy fighting illness. Their bodies could keep growing with fewer long pauses. Public health may have mattered just as much as medicine given to one person at a time. Clean water, sewage systems, safer food handling, and better hygiene reduced the constant exposure to pathogens. This kind of change is quiet. It does not always feel dramatic. A child simply gets sick less often, a stomach infection does not return as many times, food is absorbed more effectively, sleep is less often broken by illness. Over years, these small absences become height. The body grows not only because something was added, but because many burdens were removed. Sanitation, in this sense, is written into bones. So is reduced child labour in many societies, because a growing body also needs rest and protection from excessive strain. Work itself is not the enemy of growth, but heavy labour combined with poor nutrition and disease can redirect energy away from development. When more children spent their early years in safer conditions, with more opportunity to rest, learn, and recover, growth could proceed more steadily. Care also changed. Prenatal care, safer childbirth, breastfeeding support where available, childhood monitoring, and better knowledge about nutrition all helped protect the earlier stages of development. Growth begins before birth, and the health of the mother affects the child's starting point, after birth. Feeding, warmth, cleanliness, and attention during illness all continue shaping the body. Human height has always been social in this way. A skeleton lengthens inside one child, but the support comes from a larger world. In the deep past, that world was the group. In the modern world, it can include families, clinics, schools, public health systems, food networks, and social policies. When these systems work well, more children grow closer to their biological potential. When they fail, height can still be limited, even in a technologically advanced society. This is why modern height differences remain. Improvements have not reached everyone equally. Poverty, conflict, food insecurity, pollution, disease, and unequal care can still interrupt growth. The recent increase in height is therefore not a universal victory story. It is evidence of what the human body can do when childhood is protected more consistently. The same old body that once depended on gathered food, shared care, and survival through harsh seasons now responds to clean water, vaccines, varied diets, and safer homes. The mechanism is ancient. The conditions are new. Humans became taller in modern times because more children were allowed, biologically and socially, to keep growing. Modern height can be read as a mirror, but not a mirror that reflects only genes. It reflects the world that surrounds childhood. When average stature rises in a population, it often means that more children have passed through early life with better nourishment, fewer severe infections, safer water, more medical support, and less constant stress on the growing body. When average stature remains low or falls, it may point toward conditions that still interrupt growth. This does not mean every tall person had an easy childhood, or every short person had a difficult one. Individual bodies vary for many reasons, but at the level of populations, height can reveal something about the conditions under which children grow. It is one of the most visible biological traces of public health, food security, and social care. This is why the modern rise in height should not be misunderstood as proof that humans have suddenly become more evolved. Evolution did not rewrite the species in a few generations. Instead, many bodies were given a better chance to express possibilities already present in human biology. The long childhood that once made height expensive still exists. The same bones still need years to lengthen. The same hormones still guide growth. The same immune system still competes for energy during illness. What changed, in many places, was the amount of interruption. Food became more reliable, water became cleaner, Some diseases became less common or more treatable. Infants and children survived with fewer heavy burdens on development. The body's old growth system met a new level of support. That support appeared in height. This connects the modern world back to the earliest human story. The first long-legged humans did not become tall because genes alone demanded it. They grew within environments where movement, heat, food, childhood, and care made such a body possible. Modern height follows the same principle in a different setting. A child in a clean apartment, a rural clinic, a school meal program, or a household with stable food is still part of the ancient equation. Biology plus environment over time. The tools have changed. The foods have changed, the medical knowledge has changed, but the body still grows slowly, still depends on others, and still records whether the world allows growth to continue. Height also exposes inequality. If some children in a society grow tall while others do not, the difference may reflect unequal access to nutrition, healthcare, sanitation, rest, or safety. A country may appear modern while some bodies still carry old burdens. A city may have hospitals and markets, while a child in poverty still faces infection, stress, and limited food. The skeleton does not respond to national pride. It responds to lived conditions. In this way, height can be a quiet measure of whether progress has actually reached the vulnerable years of life. It asks a simple question that buildings and numbers may hide. Did children have what they needed long enough to grow? This makes height useful, but it also gives it limits. A taller population is not automatically a better population in every sense. Height does not measure wisdom, kindness, memory, skill, or dignity. It does not tell the whole story of health. Very tall bodies can have their own biological costs, and the body does not grow endlessly even under excellent conditions. Once nutrition and health reach a strong level, average height may stop rising because genetic and developmental boundaries remain. The human body always grows within limits. Still, the modern increase in height is important because it reminds us that human biology is deeply responsive. The body is ancient, but it is not frozen. It carries inherited possibilities, and those possibilities unfold differently depending on the world into which each child is born. In the deep past, that world was shaped by climate, food sources, walking routes, kinship, and danger. In the modern age, it is also shaped by vaccines, sanitation, schools, wages, housing, peace, and public care. Height stands at the meeting point of all these forces. It is not a final verdict on humanity. It is a visible sign that the body remembers conditions. To understand why humans became so tall, we must finally bring these layers together. The ground we walked on, the heat we endured, the food we shared, the childhood we extended, the genes we inherited, and the societies that either protected growth or interrupted it. When we return to the question of why humans became so tall, the answer no longer fits inside one cause. It is not only because we stood upright, though standing upright changed the whole foundation of the body. It is not only because we walked farther, though distance gave longer legs a new value. It is not only because of heat, though a long, narrow body and sweating skin helped humans move through warm landscapes. It is not only because of food, though no tall body can be built without enough energy. It is not only because of genes, though genes carry the possibilities of growth from one generation to the next. Human height sits where all of these forces meet. It is a layered result, made slowly through anatomy, environment, childhood, and social life. A tall body begins with posture. Once our ancestors became more committed to walking on 2 feet, the legs became more central to survival than before. The hips, spine, knees, and feet carried the body in a new way. But standing upright did not automatically make humans tall. It only opened a path. The path became more meaningful when landscapes widened and daily movement stretched across greater distances. In those worlds, a longer stride could reduce the cost of travel. A body that moved more efficiently might reach food, water, shade, or safety with energy left over. Height, then, was not merely upward. It was also the shape of range. It belonged to the ground crossed again and again by living bodies. Heat added another layer. Moving through warmth creates danger inside the body. Muscles produce heat, and the body must release it. Human sweating, reduced body hair, upright posture, and longer proportions became part of a cooling system that supported endurance. But this system created needs of its own. Sweat required water. Long limbs required years of growth. A slender body could lose warmth in cold places. Every advantage remained tied to a cost. Food made those costs payable. Without enough nourishment, long growth stops early. Tools, varied diets, animal foods, plant foods, processing, cooking in later human life, and sharing all helped widen the energy available to human bodies. The skeleton did not grow from intention. It grew from meals, recovery, and the repeated arrival of enough resources. This connects height to the deepest human beginning, because our bodies were never only individual machines. They grew inside groups. Human childhood made this even clearer. A tall adult is the result of a child who had time to remain unfinished. That long childhood allowed learning, brain development, skill, memory, and social understanding to grow alongside the bones. But it also made humans dependent. A child could not become tall alone. Care made slow growth survivable. Food had to be shared. Illness had to be endured. Protection had to continue through years of weakness. In this sense, height is one of the quietest signs of human social life. It shows that the body was carried by others before it could carry itself. Genes and hormones guided the process from within, but they never freed the body from the world outside. Disease, hunger, sanitation, climate, workload, migration, and inequality could all alter growth. This is why height has varied so much across human history. People became taller in some places and shorter in others. Farming sometimes reduced stature despite creating larger societies. Modern public health sometimes increased stature without changing human genes. The story bends because bodies grow inside conditions, not abstractions. So humans became tall not through a single victory, but through a long balance of pressures. The body rose because the ground demanded movement, the heat demanded cooling, food made growth possible, childhood gave growth time, and social life protected that time. Height is not the whole story of being human, but it is one visible trace of how deeply our bodies belong to the worlds that made them. A human body is often treated as if it belongs only to the present. We measure it, compare it, clothe it, and move through the day inside it. But the body is older than the person who carries it. It holds traces of deep ancestry, long environments, childhood conditions, and the care of others. Height makes this especially clear. No one grows tall by will alone. A tall body requires inherited possibilities, but it also requires food, health, rest, protection, and time. It requires a childhood that is not broken too often by hunger or disease. It requires a world that allows growth to continue. This gives the story of human height a quiet educational meaning. The body is not only a private possession, it is a record of relationship. It records the relationship between a child and nourishment, between a group and its vulnerable members, between a population and the land it lives on, between generations and the conditions they pass forward. When we ask why humans became so tall, we are also asking how a fragile species learned to support fragile young long enough for a costly body to emerge. That question softens the way we look at ourselves. Height is easy to admire, but the deeper wonder is not in the number. The wonder is in the process that made the number possible. A child had to be fed before the child could gather food. A child had to be protected before the child could protect anyone. A child had to learn before the child could use knowledge. Long bones grew while other people carried the burden of dependence. In this sense, every adult body contains an older truth. Before we stood tall, we were held. This is not sentiment added to biology. It is part of biology itself. Human beings evolved with long childhoods, and long childhoods require care. Without care, slow growth becomes dangerous. With enough care, slow growth becomes one of the foundations of human life. The same principle reaches into modern society. When children receive clean water, good food, medicine, safety, and attention, their bodies may grow more fully. When those supports are missing, growth may be limited, even if the child carries inherited potential. This does not make one body more valuable than another. It makes every body a witness. Some bodies witness abundance. Some witness hardship. Some witness ancestry adapted to heat, cold, distance, or scarcity. Some witness recent improvements in public health. None of them should be used to rank human dignity. The lesson is simpler and more humane. Bodies are shaped by conditions, and conditions are shaped by human choices. If height has risen in many modern populations, the most useful response is not pride. It is responsibility. It shows that when societies protect childhood, biology answers. When food systems improve, when disease is reduced, when care reaches the young, the effects can become visible in the next generation. Our bones remind us that care is not abstract. It becomes tissue. It becomes strength. It becomes the chance to grow. Looking back across evolution, this same message appears in a slower form. Our ancestors did not become tall because they escaped dependence. They became tall because dependence became survivable. The human body rose through walking, heat, food, genes, and time, but it also rose through shared life. It was shaped by those who found food, carried children, remembered water, guarded rest, and kept the young alive through seasons they could not understand. The value of the story is not that tallness is the final achievement of humanity. The value is that the body teaches interdependence. It teaches that what happens to one generation enters the next through growth, health, and possibility. To understand human height is to see that evolution did not make us separate from one another. It made us creatures whose bodies carry the evidence that survival has always been shared. A tall human body is not the final answer to evolution. It is only one of the ways life has carried a question forward. The question began long before modern cities, long before written records, long before anyone could measure a child against a wall. It began when our ancestors moved between trees and ground, when balance shifted over the hips, when the feet became platforms, and when the legs slowly became the main path through the world. It continued under heat, across distance, through hunger, illness, shared meals, long childhoods, and the patient care of others. Height was never simply added to humanity. It was earned by bodies that survived enough seasons to grow. It was limited by bodies that faced too much sickness or too little food. It rose in some places, fell in others, and changed again when human ways of living changed. That is why the answer cannot be reduced to a slogan. Humans became tall because many conditions made tallness possible. Upright walking gave the body a new foundation. Open and mixed landscapes made travel important. Heat made cooling necessary. Food made growth affordable. Childhood gave growth time. Genes guided the inner rhythm, and social care protected the vulnerable years. Yet every one of those causes also carried a cost. Long legs had to be built. Sweat needed water. A large brain needed energy. A slow-growing child needed protection. A tall adult stood at the end of many dependencies. Seen this way, height becomes less like a victory and more like a memory. It remembers the ground our ancestors crossed. It remembers the sun above them, the food they found, the children they carried, and the risks they endured without knowing they were shaping the future body of their descendants. It remembers that evolution does not lift every life in a straight line. Farming could make societies larger while making some bodies smaller. Cities could rise while children struggled with disease. Modern medicine and sanitation could help bodies grow taller again, not because humanity suddenly became new, but because childhood became less interrupted. The human body is still answering its surroundings. It still grows through conditions. It still carries old limits. It still depends on care. This may be the quietest lesson of the whole story. We are not tall because we escape nature. We are tall because nature, culture, food, disease, climate, and care have always worked through us together. Our height is not only in our bones, it is in the history that allowed those bones to lengthen. It is in the generations that survived before us. It is in the hands that fed children who could not feed themselves. It is in the knowledge of water, shelter, timing, rest and return. It is in the fact that no child grows alone, even when growth happens silently under the skin. Every centimetre depends on a world, a mother's body before birth, a caregiver's patience after birth, a community's food supply, a landscape's generosity, and the fragile absence of too much disease at the wrong time. This makes height both ancient and immediate. It belongs to fossils in the ground, but also to living children in the present. It tells us that biology is never separate from mercy, because the body often grows best where vulnerability is protected. And it is also in the fragility of the future, because the body that grew under ancient pressures will continue to respond to the world we build now. If children grow in safety, nourishment, and health, the body may show one answer. If they grow in hunger, disease, stress, and neglect, the body may show another. Height, then, is not a closed conclusion. It is a living conversation between inheritance and circumstance. The deeper question is not simply why humans became so tall, but what our bodies will remember next. If the human form has always changed according to the worlds that carried it, what kind of body will future generations inherit from the world we are making today?